Hello, grade eights. We are going to be getting into order of operations, so bed mass with integers. But before that, I thought it was a good idea if we spent a bit of time reviewing adding and subtracting integers. This is something that we did a chapter on in grade 7, but that's been a while. And also, this is probably harder than multiplying and dividing integers. Multiplying and dividing, we have some rules that we can always use for multiplying and dividing. Addition and subtraction is a little bit more complicated. So we're going to do a bit of review right now. Just a reminder, and when I'm using my integer chips, today I'm going to use an empty circle is going to be negative, and a filled in circle is going to be positive. Okay, so I'll do some with integer chips, but then we'll just also sort of talk about how we can think about it. So I'll get this in there. There we go. Okay, so I just have a bunch of examples. So here I have minus 5 or negative 5 plus positive 12. So I have negative 5 and I'm adding a positive 12. So I always like to look at what I'm doing to my first number. So since I'm adding a positive, that means that my number is going to be getting bigger. So if you're thinking of where negative 5 is on a number line, it will be moving, getting bigger. It will be going past 0. That's one way that you can think about it. When you're adding a positive person into your group, overall your group is going to become more positive. So numbers getting bigger by 12. We can also use integer chips. I have 5 negatives, so I have 1, 2, 3, 4, 5. And since I'm adding, I can also just draw in 12 positives. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so here's my 5 negatives. Here's my 12 positives. Now you have to remember 1 negative, 1 positive together is a 0 pair, so that's equals 0. This is equal 0, 0, 0, 0. And so all of those cancel out. And so what I have left here is my answer. 1, 2, 3, 4, 5, 6, 7 positives. So my answer is positive 7. Okay? Another way you can think of it is if you're on that number line. I don't like drawing number lines, but it can be helpful. If you're at negative 5, since I'm adding positive 12, my number's going to be getting bigger. I'm going to be moving 12 spots over to the right. Okay, so I'd go from negative 5 to negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. Whoops, I didn't do enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 7. So I got up to positive 7 over here by moving 12 spots to the right. Okay, let's look here at this question. So I have positive 12, so that's where I'm starting, and I'm taking away from positive 12, I'm taking away negative 21. Okay, so let's think about taking away a negative. If you have a group of people and you remove a negative person, so you take away a negative person from your group of people, overall your group's going to become a more positive group of people because you remove that negative person. Okay, so removing a negative actually makes you more positive. So again, this number is going to be getting larger, and you can just think of that when you imagine removing a negative person from your group. Let's quickly look at this with integer chips, how we do it. Oh man, I'm going to have to draw so many. So we have 12 positives, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I have to take away 21 negatives. Well, there aren't any negatives in my diagram here to be taken away. But I can add negatives to my diagram while still leaving it as overall positive 12 if I add a bunch of 0 pairs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, oh boy, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, So now I added 21 zero pairs. So overall, this picture, this drawing that I have of integer chips, still only shows positive 12 because I have a whole bunch of zeros with these zero pairs. But if I take all of those negatives and I take them away, right? I'm subtracting them. I'm getting rid of them. Suddenly, all that's left are all of these positives, and I had my 12 original positives plus these other 21 positives I drew with the zero pairs. So this is actually like 12 plus 21, which gives me positive 33. This makes sense. I was at 12. Taking away a negative makes your number bigger. I get to positive 33. So maybe that with integer chips is a little bit confusing. I'm just going to remind you of a rule that we have, which is the keep, change rule. Okay? So we do keep, change, flip for fractions, but if you remember to grade 7, keep, change is what we do for adding and subtracting integers. So I can keep my first value as positive 12. I can change my subtraction to addition. And I can change my negative 21 to a positive 21. And now I get 12 plus 21, which is just regular addition now, which is 33. Okay, so anytime you're subtracting a negative, it's actually the same as adding a positive. So you can keep, change. It's the same as doing the opposite. So that's actually a helpful little rule. You can always do keep, change, but it's not always helpful. So let's scroll down here a little bit. Hey, come on. There we go. So let's go to this question here now. We have negative 8, and I'm adding a negative 15. So if you have a group of people and you add in a negative person, overall your group's going to become more negative. So I'm starting at negative 8, and I'm actually going to become more negative by a value of 15. So if I was on my number line, that would be going down or to the left by 15. I can also think of it with integer chips. Addition is easy with integer chips. If you're doing addition, it's great. Subtraction is a little bit more confusing. But I have 8 negatives. 1, 2, 3, 4, 5, 6, 7, 8. And I'm adding to that 15 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I had 8 negatives. I'm adding another 15 negatives. How many negatives do I have? Well, in total, I have 23 negatives. My answer is negative 23. Okay? So adding integer chips always work well. If I have a negative and negative with adding, they just combine. When you have the negative and the positive, like we had up here, a negative and a positive we were adding, then the zero pairs cancel each other out. But in this case, since they're both negative, negative 8 and negative 15, there's no zero pairs. So my answer is negative 23. Now remember, you can always do the keep, change rule. But here, if I keep, change it, I get negative 8 because I keep that the same. I change this to subtraction, and I change negative 15 to positive 15. This doesn't, to me, make my problem any simpler. Negative 8 subtract positive 15 isn't any easier. In fact, I see subtraction questions as more difficult than addition questions. So I just like to use the keep, change rule to turn subtraction questions into addition questions. So if we look at their next question here, negative 7 minus positive 4, we're taking away a positive, so overall we're becoming more negative. I could show this as well. If I keep, change it, keep, change, I get negative 7, so I keep that the same, change subtraction to addition, change my last unit to whatever it is, flip it to its opposite, it becomes a negative 4. And now I have negative 7 plus negative 4. Well, I have 7 negatives. I'm adding 4 more negatives. How many negatives do I have? 1, 2, 3, 4, 5, 6, 7 negatives plus 4 negatives. 1, 2, 3, 4. In total, I can count those up. I have 11 negatives. So my answer is negative 11. Okay, so I like to use this keep, change rule to change every subtraction question. Well, not every, but lots of subtraction questions into an addition question. Because addition questions with integer chips are easy. And addition, usually, to most people, just makes a little bit more sense in your brain. Okay, let's go over some more examples. Negative 15, I am taking away negative 8. Okay, so this is one case where you may want to change it. That's sort of up to you. I also don't mind when I have this. I just have to think about what my situation is telling me. So I'm saying I have 15 negatives. I am taking away 8 negatives. What am I going to have left? Well, if I have 15 negatives, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I took away 8 of them. So I take away 1, 2, 3, 4, 5, 6, 7, 8. What do I have left? I have left 7 negatives. So my answer is negative 7. This makes sense. When I think about taking away a negative, my answer is going to become more positive, and negative 7 is closer to 0 than negative 15. So it's actually a larger number. Okay? You could flip this, and then you get negative 15 plus positive 8. Okay? And then you could still draw your negative 15 negative integer chips, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then I could draw, I'm also adding in 8 positives now. 1, 2, 3, 4, 5, 6, 7, 8. Adding positive and negatives makes 0 pairs that cancel out. I'm really doing the same thing that I did before, and I'm left with my answer of 7 negatives. So either way gets you the same answer. Okay, this example right here, I have negative 12, and I'm adding to that 15 positives. I'm adding 15. My answer is going to be getting larger by 15. So if I was on the number line, let's go back to this idea. If I'm at negative 12, since my answer is getting bigger, it's going to move to the right by 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I was at negative 12. Moving up would be negative 11, negative 10, negative 9, negative 8, 7, 6, 5, 4, 3, 2, 1, 0. That's where 0 would be. And then positive 1, positive 2, positive 3. So I moved up to the answer being positive 3. I could draw my integer chips as well. 12 negatives, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 15 positives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 12 negatives, I have 15 positives. 12 of those turn into 0 pairs. I'm just left with 3 positives, which is my answer. Okay, so a couple ways of looking at how to solve that. Scroll down. I have positive 32, and I'm adding a negative 50. Okay, positive 32, adding negative 50. You could actually this is one situation where with an addition problem, if you change it, change it, you get positive 32, and you're subtracting positive 50. Maybe for some of you that's easier to think. Either way, if you're adding a negative or you're subtracting a positive, either way your answer is getting smaller. Because if you add a negative person to your group gets more negative. If you take away a positive person from your group becomes more negative. Okay, so either way, we're going to be getting smaller by 50 from 32. Okay, so you could draw out integer chips. Some of you might also just be able to do this in your head and think, okay, I'm at 32, I'm going down by 50. Well, if I went down by 32, I would get to 0. So how many more would I need to go down to be down by 50? And that's really the difference between 32 and 50, which would bring me down to negative 18. Okay? Positive 21 minus negative 55. This is a great one to keep change. Okay, it's always a good idea to check to see if keep change helps. Positive 21, keep that the same. Change subtraction to addition. Change my second value. In this case, it becomes positive 55. Hey, now I just have 21 plus 55. They're both positive. So just regular addition. 21 plus 55. You guys can do it this way if you want. That's a 6. 5 plus 2 is 7. Hey, the answer is positive 76. Okay? So addition and subtraction can be hard. Some people's brains just sort of understand what they're doing and what way to move. Other people, it's pretty hard to visualize and understand. Remember your keep, change, change rule. Always try that. See if it makes the question seem easier to you. Just try to say the question in a different way. So instead of saying negative 15 minus negative 8, say I have 15 negatives, I am taking away 8 negatives. To me, in my head, that's like, oh, if I have 15 negatives and I take away 8 of those negatives, how many negatives will I have left? 7 negatives. That's just 15 minus 8, but talking about negative numbers. Okay, so there's lots of different ways to solve addition and subtraction questions. Using integer chips can be helpful, and zero pairs, especially with addition, because then you just draw all your integer chips, and then if any positives and negatives make zero pairs, you cancel them out. And yeah, hopefully one of those ways makes sense to you. Watch the video again if you need to. Make sure you're asking questions. This is sort of, one of the more challenging parts. People often figure out the multiplication, division, and then still struggle with the addition and subtraction. So don't be afraid to ask for help. I will be available online if you need me, so feel free to connect.